Well, good afternoon, ladies and gentlemen. Up here on the beer, blood, sweat, tear covered bench, we got the control box for an RPC of 5 horsepower, actually hooked up to a 5 horsepower motor. This 5 horsepower motor is an inverter rated motor. It'll run the same at 60 hertz as a conventional 3-phase motor. The characteristics of it running may be a little bit different or whatever, but for testing purposes, to assure that the box functions correctly, we went ahead and mocked up this motor. The motor is usually used to being driven by a VFD, and I wouldn't recommend this practice for this type of motor, but it fires right off, so I don't think there's too much damage being occurring. But then again, though, if you're doing this stuff in the first place, you're kind of taking your stuff at your own risk and all that. Enough said on that anyways, but basically what we got here, we have the incoming power to this side of it. This is single phase. Here's the red, here's the black, here's a ground wire, and it's going to a 30 amp breaker. The 30 amp breaker is off right now. This is just to, in case there's a line-to-line short or something, this circuit breaker will pop at 30 amps. What we got here is a start capacitor. The range on it is 340 to 408 microfarads. I guess that's the range for the capacitor. It's 250 volt rated. So what we got here is it's a 60 amp contactor, but you don't need to put that much in it. I just did it just because I had it laying around here. I have a start switch and a stop switch. Hidden way back there is a relay that will deliver the start capacitor charge to this 3-phase motor. Okay, so the way that this contactor is working here is we're switching single phase load, adding a capacitor charge to it. Once the motor fires up, it sends a charge back through this white wire, well, that's painted partially blue to indicate the 3rd phase, and it's stopped from doing anything else by the relay. But if a wire is tapped anywhere onto this, it uses the 3 phases that this motor will produce afterwards. So we're going to go ahead and turn the power on here, and we'll go ahead and fire it off. Okay, so when you go to fire this unit off, it's very important that you just don't push the button and jump off of it. This is operating 2 circuits at the same time. One of them is a hold-in circuit for the, a pull-in circuit for the contactor. One of them is the pull-in circuit for the capacitor relay. So since it's a momentary switch, as soon as we let off of it, well, it opens circuits back up. We want to make sure that this motor is running before we lift our finger back off of it, and usually 1 to 2 seconds is sufficient, but you'll hear it come up to speed relatively quickly with this. So with no more ado here, we're going to go ahead and so that's it. I mean, once that motor is up to speed, this is a 1740 RPM nominal motor. It is wired in the Y configuration. You can hook these up in Delta if you feel like it, and it will have lower starting torque, or excuse me, lower starting amperage, and it's another way of doing it, but they seem to be very happy on Y winding here. This motor doesn't seem to be laboring, doesn't seem to be having any issues at all. Let's go ahead and do a voltage test here. just so you guys can see how this performs. We're going to be very careful not to get anywhere near that motor shaft with these leads. Alright, so you guys aren't going to be able to see the meter reading here, but it's just a convenient place to put this meter for me. So let's go ahead and we're going to pick 750 volts here just to get that kind of resolution. Okay, so on the input side of it, okay, which is the left side, we're going to go ahead and take the voltage reading there, and don't mind if it's buzzing here. We got my voltage is kind of high here, 270 right this second. This is what I'm okay. So on this side of it, we're gonna go ahead. Yeah. And it might be a function of this motor running at 60 hertz. Okay, so coming into our third leg here, we're showing 237 volts. Okay, now and that is to the red phase. Let's go ahead and go from the black phase. (247 volts). So these voltage readings may be different than the ones that you have in your shop. When you push the stop button, the contactor drops out and all the power is being removed. What I will do here is we're going to go ahead and disconnect these leads after this motor shuts off, and we'll actually do a amp test while it's running here. Okay, so we're going to set it on the 200 resolution. Okay, we're going to select the black lead here. So this motor is quite efficient. It's idling here, very happy at we'll call it 7 point, it's still going down here. We'll call it 7 amps. Let's go ahead and test the next phase here. We're putting a little bit more juice on this one. This one is 8. Okay, and this third phase with the blue wire will test absolute 0. There's no amperage going through that one because it's blocked by a switch and it's not part of a circuit. But believe it, there is voltage sitting there, and if you happen to touch it and not know about it, you're going to get hit. So treat pretty much this and every other electrical device like it's a rattlesnake, and you'll be alright. So I'm going to take a brief moment here to we're going to shut off the circuit breaker, disconnect my power source. Okay. So the way that this one's tapping out here is we have the black wire. I got this one hooked up to T7, T1 junction. The red wire, I got T3, T9. The third phase, the generated false phase here, is T2, T8. On the low voltage on this motor, we have 4, 5, 6 that are shorted, and I put a bit of the shrink wrap on it and did it up real nice. But since this motor's not going to end up going with this converter. I just left the wires here to show the guys how to hook this thing up, but hopefully this is what you need.